Okay, so today we're learning about volumes by cross sections, and basically this is the next topic that we learn after area between curves because we're just building off of that idea. All right, so if you've already read this was just, it's very wordy and might not make sense to you so much, so I'm just going to kind of break it down. Is that when you have a volume by cross section, I want you to think of like this stack of quarters, right? If I just have one quarter, it's very flat, it's almost like your two-dimensional, right, shape. And then if I start stacking that, what happens is it accumulates and it becomes a three-dimensional shape. And we basically know that. We know that when we integrate of two-dimensional area shape, we end up with volume. And the reason why we know that's true is that we know it goes up by a degree, and we know that area is feet squared. So if I was to integrate feet squared, I'd end up at feet cubed, okay? And feet cubed is volume. So that idea is not new. So today's topic is how do we calculate that volume by using a cross section? Well, if I take a cross section, I'm basically slicing that three-dimensional shape figure and pulling out a two-dimensional shape, and this two-dimensional shape happens to be a circle. But you're going to see they're going to tell you the shape. They're going to tell you, hey, it is a semicircle, it's a square. That needs to be told to you. The other piece that needs to be told to you is the orientation of your figure. Is your figure leaning toward perpendicular to the x-axis, or is it perpendicular to the y-axis? Now that's really important, because if I look at this sideways, all right, and I decide this is my x-axis, this is my y-axis, well, if it's perpendicular to the x-axis, envision this being standing on that x-axis, okay? If that's the case, in a circle, it doesn't make that big of a deal, but let's say it was a square, the base, okay, would be laying on that x-axis, and I would be consider the base to be from top to bottom. Remember, we did area between curves, top minus bottom. If it was to the y-axis, it would be right minus left to find the base if we were dealing with a square. So this will make a little bit more sense once we start making problems, practicing problems. But the two major pieces of volumes by cross sections is, first of all, identifying you have a volume by cross section question. They're literally going to say, find the volume created by the cross section, and you're going to go, okay, this is the volume by cross section. What is the two things I need to know? I need to, one, know the orientation of the problem. When I say orientation, I want to know, is this shape, to what axis is this shape perpendicular to? So I'm perpendicular to what axis? This is really important. If it says that I'm perpendicular to the x-axis, well, then my integral is going to be in terms of x, the integrand, and the variable of integration is going to be dx. If I'm perpendicular to the y-axis, well, I'm sure you got it, it's now going to be a dy problem. That means the bounds are y, my integrand is in terms of y, and this is x, and this is in terms of x, okay? So if I know the orientation, what is perpendicular, then I can figure out how I want my equation. Can I work with the equation the way that it's given to me, or do I have to rewrite it in terms of a different variable? The second piece, just as important, is what shape am I talking about? Am I talking about a square? Am I talking about a semicircle? Am I talking about a quarter of a circle? The shape is going to tell you the area formula that you will use. So if I happen to be integrating a cross section that's perpendicular to the y-axis, this is going to be in terms of dy. And then I'm going to say, well, what's the formula of a square? Well, it's side squared, and then it's going to be up to you to find the side. Okay, so that is going to be the idea behind this lesson. So let's get to some practice problems. The first one, I already highlighted this. So I went ahead and read the directions, and it basically said that I had an equation x equals y squared, x equals 9. They say find the volume of a solid, and they said cross section popped up and I'm perpendicular to the x-axis. Okay, as soon as I say I'm perpendicular to the x-axis, I say dx. And it happens that this is the same directions from 1 through 8, and I just gave you 1 through 3 on this worksheet. The first shape is a square. So I go, okay, I'm going to redraw this for you just so you understand how I'm going, why the shape is important and why we write the integrand in a specific way. So here they're showing you y and x, as this is going to be an aerial view, if you can envision that, all right? So basically you're like standing on top of it and looking down, and you see that flat surface. You know y squared is a sideways parabola. That's not new, okay? And you're trying to find the cross section when the shape is perpendicular to the x-axis. So if I have a square, I want you to envision the base of that square is laying on this shape, but that's the base, okay? And then the square, envision my drawing to be somewhat decent, which it's not. And that's this red piece, envision that standing up, okay? And that I have a bunch of those, right? Believe it or not, that would almost look like a loaf of bread if you kind of see that like coming. Oh boy, you're gonna see how bad my drawing is. Actually, I'm probably just making you laugh at my bad artistic skills, okay? And that's what your three-dimensional shape would be on top, okay? So going back, I know that if I integrate the area here, well then I'm going to get my volume by that cross section. So I know that the shape is a square. So here, if the shape is a square, I want to put as the integrand the area of how to find the square. Well, I know the area of a square is side squared. Okay, so one more piece here. I need to figure out how do I find the length of this side. Okay, sometimes it's going to be back to the old way that we did it, top minus bottom, if we had two formulas. But here, they're telling me that the equation was x equals y squared. I know I need it in terms of x because the variable of integration is dx. Now, I basically don't have to do any work on this because they're giving it to me, but I'm going to show you where they came up with that. I would change my equation to y equals, and when I square root, I get plus and minus the square root of x. So you have two equations. I have that this is the y equals square root of x, and the bottom here is y equals negative square root of x. So this point here, as labeled in the diagram, is x comma square root of x and x comma negative square root of x. Okay, well then that means that at this point, at this x value, I went up square root of x, and this x value, I went down square root of x. But if I'm looking for length, I'm not looking at negatives. What is this whole side? Well, that's going to represent 2 square root of x. So hopefully that makes sense that that top to bottom here, okay, is represented by 2 rad x. So what am I going to do? I'm just going to say, well, that is what is the side that I want to square. So I'm going to write as 2 rad x squared dx. And now I got to think about my bounds. Well, they told me x is equal to 9. And think about it. I'm at this equation here, x equals 0. So it's stopped at x equals 9, which is, let's say, over here, that's where the drawing is, 9, and this is 0. Those are your bounds. And now you're just going to clean up the integrand. When I do that, you get 0, 9, 2 rad x squared is just 4x dx. And so now you just go ahead and do your basic integration. This becomes 2x squared, and then you do the FTC, 2, 9 squared minus 2, 0 squared, and this becomes 81 times 2, which is 162, minus 0, and your volume by cross-section is 162 units cubed. All right, so let's see if we understand how to do the next part. Here on the second page of this worksheet, they're telling you now the shape is a rectangle with a height of 2. Okay, now just so you got too comfortable, we didn't change the directions. It's still the same equation. It's still saying the volume of cross-section, and it's still perpendicular to the x-axis. So therefore, for number 2, you're just going to go, okay, it's perpendicular to the x-axis. I know that it's a rectangle, so I'm going to write myself here, base times height. That's how you find the area of a rectangle. Well, they told me the height is 2, okay, and then I want to know the base. Well, this is the same shape, right? We already said that the base this was x rad, x comma rad x, and this was x comma negative rad x comma negative rad x. So we said this was 2 rad x. So no different, and this is still being 0 and 9. So now you're just going to set this up, and honestly for today I'm not going to go ahead and do all I'm just going to set them up for you, because I do think that you can do the rest by hand, and we can check on Wednesday if we match up. So I want you to go ahead, just for practice, do the FTC on this, but this is your setup. This is the volume by cross-section. That is what my volume is going to equal. Okay, let's try the next one, which is a little bit different, a little bit harder. Okay, so here we have a semicircle, they tell me. And so then I have this picture, and I already know that this whole thing, this is rad x and this is negative rad x, but now I need to think to myself, all right, how do you find the area of a semicircle? For number 3, yeah, I'm going to do, it's still from 0 to 9 because it's the same exact directions, it's still dx. Well, the area of a semicircle is pi r squared divided by 2. That's your integrand. The area is always your integrand. Okay, well, what is my radius? This is a diameter, 2 rad x, so don't go quickly picking the same exact number. So 2 rad x is the diameter, so the radius is just rad x. So I'm going to say, okay, it's pi, and then it's rad x squared divided by 2 dx. So then it's going to just be x pi over 2 dx, and that's your setup. And you could, of course, write this as 1/2 pi x dx if you'd rather, okay? So, and then don't forget the bounds. It's from 0 to 9. That was the same. Okay, so this piece hopefully made sense, but the next video that I'm going to do is a worksheet, and it switches from dx and dy, and it switches shapes. So I want you to practice those 3 problems with me, and then try the rest for homework. Okay, so watch the next video.